Hello, and welcome to my talk today. My name is Tim SPann. I'm a developer advocate for Apache Pulsar. I also work with Apache NiFi, Flink, Spark, and a lot of other interesting projects. My talk today at ApacheCon Asia is entitled Citizen Streaming Engineer How To. I have been working with a number of streaming technologies for a couple of years, and I've come up with a couple of patterns or ways of working with applications that kind of minimizes the amount of coding, tries to make it as straightforward as possible so that anyone out there who's needs to build an app, maybe just to get data from one point to another, or need to get it into some kind of data lake, lakehouse, database, make this as easy as possible so that people whose first job isn't being a streaming engineer can write these applications. And that's what I'm going to attempt to do today. So hopefully I get you, if I don't get you to being a full-fledged streaming engineer who could build some apps, we'll get you as close as possible, or at least get you to the point where it's not a mystery at every step of the way. So I thought the easiest way to start is to show you a reasonably complete application, show it running, go through a couple of the steps, source code, all of which is available in GitHub, so you can just download it, try it yourself, and show you how we can build these apps, how you can make decisions on, okay, where should I write code or use code from someone else? How can I minimize the amount of coding I have to do? So let's walk through this application. So in the beginning, there's a couple of sources of air quality data that I want to use. Both of these are REST endpoints. They live in the cloud and generally pretty easy to access. They'll usually give you a way to test them and you get results back. So you can look at it and say, okay, I have an idea what the data is going to look like, maybe even have examples. And in this case, and very often is the case when you're building these type of apps where I want to get data from a source, do something with it, maybe store it somewhere, it's often JSON. And if that's the case, that's pretty good because most people can basically read JSON, its fields and values. Formatting may be a little weird, but it's something you could do. So I'm doing this a couple different ways just to show you, which way maybe a full engineer would do, which way that you could do as someone who hasn't spent 15 years writing complex backend code. Now there's a magic keyword in there. Another great Apache project, Apache NiFi. The reason why I'm emphasizing this one is this really screams citizen engineer, citizen developer, citizen streaming engineer, because it's drag and drop. And once you've gone through some examples or used some of my examples I have out there in source code, it's pretty easy to replicate this. And I've had this done at a couple of nonprofits where they can't afford to be hiring, dozens of engineers. It's pretty straightforward. And we're pulling from air quality with NiFi there. We push that data into Pulsar, which is very straightforward. I'll show you that. The reason why we're doing that is once I get it into Apache Pulsar, and hopefully you'll have either using one of the cloud hosted ones or someone spun it up for you in Kubernetes. It's also pretty easy if you want to run it yourself with Docker. It's, single run there. Once you have it in Pulsar, it's very easy for it to be distributed. So I have it. Once you've gotten the data, it's secure. It's in order. It's got a timestamp. I know I have data, I could use it. And one of the ways you could use it, I can create a sink. And Pulsar has these sinks that are no code. You do a little configuration and you could automatically have that push to a data store. And that can be anything from a Scylla database. It could be Elasticsearch. It could be Solar. It could be an S3 bucket. It could be a file system, any kind of database. We have JDBC to point to them. Lots of different endpoints you could easily get that data into, and you could just be done then, and no code. NiFi grabs my data, got it into Pulsar to keep it safe and distribute it, and then have it automatically stored somewhere. And that's a very, very good use case and a great use of not having to write code. Today, we're going to do a little more than that. When we get that data in, it's not in the format that my data engineer wants, that my data scientist wants, that I want. So I'm going to clean it up a little bit. Now I could do that manually, maybe in a Jupyter notebook, but with a little bit of code in Java or Python, I can write something we call a function. It's a few lines of code, maybe a little longer. It runs in Pulsar, so I don't have to buy some other server or figure out how to deploy something. It's a very simple one push script, deploys it for you. And as the data comes in, for me, it's going to split the data out because unfortunately my feeds decide that there's a lot of different air quality and they're going to put them all into one chunk of data. Well, that's not how I work. I want to know, PM 2.5 air quality and PM 1.0 data, and I want to know ozone. I want them separately. So if I need to do analytics on them, I could do that. So I'm going to separate those out into separate topics. So then anyone who needs that data, it's now available to very easily consume. And consuming data from Pulsar is very easy. You don't need to be an engineer. You don't need to write code. You could do that with something like Spark, with just a simple couple lines of SQL, and we'll do the same in Flink with some SQL, or it could be NiFi consuming it. Or, like I said, very simple Python code to consume it. Lots of different things can consume the data once I've got it into these Pulsar topics. Another great reason why I want to do that. Of course, I could also put one of those no-code syncs in there, so that data just goes, it gets saved to a data store for me. Very easy. If I need to do a little tweaking on it, maybe I could do a little simple Spark, or maybe someone could help me there and I could do a little ETL, get that into CSV or JSON or Parquet or Delta Lake and get that into a data store for, more advanced work. That's the idea. Let's look at it in practice and see how well that's going. So hopefully all of this is working. Even in simple demos, there's a lot to keep your eyes on. So what I have here is an application that's grabbing the data. As we mentioned, maybe I don't want to write code. Maybe someone will write this code for me. There's also third-party services that can read that REST and push it somewhere. They could probably push it to Pulsar. Things like Decodable will do that. So that makes it pretty easy. Here I've got a Java app. I don't want to have to write Java, but there's Java written there. If we don't want to do that, we could come into something like NiFi. As you see here, this is running on one of my local machines here. You can run it in Docker, little Kubernetes, anywhere on the internet. And what's nice here is this will graphically run things for me. So I want to be able to invoke a REST endpoint. All I have to do is put my URL in there, and I could just copy it from their web page. And again, you could download this code and do it. So what I have here is this is just iterating through, because there's a lot of different endpoints to get data from, maybe thousands of them. So I'm just having them run. I'm going to run this once just to get some data running through. And I'm just going to clean up the data a little bit. What's nice is no code. Let me just split it on that field. Let's see what the data looks like. This is a nice feature of NiFi that makes it very applicable for people who maybe aren't developers, but I can see the data as it's coming through the system. So it makes it a lot more straightforward, because you could see things as they happen and make decisions and do that step by step. Once I get the data, I could take a look at it and I could say, okay, I understand this data or I don't. What should I do next? And then do that next step. Like here, I looked at it and I could see some fields that I liked and some fields that I don't. Let me just grab the fields I want and build a new file from that, just a list of fields I want. Again, not having to write any code to do that. It just lets me build up a new JSON file with pretty reasonable fields that make sense to me. You know, dates, where the data came from, what kind of unit of measure, lat long, you know, where is it? You know, what's the value? Those sort of things makes it straightforward. So that data is coming through the system and I built a new file with it. Here, I'm doing just some simple SQL. Again, SQL is definitely the language that you have to know. If you know SQL, you don't really have to write any other code. Like here, I'm going to limit things to just the PM10 values and, you know, where it's greater than 8. And if that's the case, I filter it down here, and then I'm going to push it to Pulsar that I've got running in a StreamNative Cloud somewhere. And that's a topic. You name it the way you want. We'll go into that a little bit. But that's all you have to do to push data somewhere. Like, this is just going to run for me. I don't have to do anything. What's cool with NiFi is if I'm not ready for something to run or if I want to debug it, I could start and stop it without losing data. Here it's just waiting for me, queuing up, which is nice. And I can see, okay, did that data work? What did it look like? Okay, one message went into here. Then I can go check out that topic, look at the data and say, okay, this is what I expected it to be. This is good. You know, if I want to just test it one at a time, I could do that, or send a whole lot of data through, depending on my use case. I could do a refresh, see how quickly those rows are being processed. This is what it takes for you to read data, edit it, and send it to Pulsar. Now, if I wanted to directly store it somewhere, like here, I could just put it in a file, or if I wanted to put it somewhere else, it's pretty straightforward in NiFi, as long as I have a place to put it and, you know the parameters I need. You know, if I need to push that into a database, I could do that as long as I know how to connect to it, have a username, password. You know, ask your database administrator for that, or maybe create your own in a local data store. Easiest is, let me just drop it in a file somewhere in a directory, and then I could figure that out later what I want to do with the data, because these are just standard JSON records if you look at them. So I could download all these, you know, and if you wanted to test them later. So this is what the file is going to have in it. It's just JSON, but this gives me, you know, what's going on with the data, what type of data, that sort of thing. Makes it pretty straightforward. So that is one way to get your data. And it's pretty easy to do that with air quality or wherever else this data may come from, whether it's sensors, whether it's logs, you know, wherever your data may be coming from. Here I can consume the data and convert it into another format, maybe store it somewhere, whatever makes sense for the data that you have. And this source code is out there, so you can use it. So we've got data coming in from NiFi. We showed data coming in as well from our Java application. The Java application is fully documented here. So if you want to take a look at it, I don't want to dive into Java code. That's not the most citizen-friendly language, but pretty easy for someone to generate one of those for you if you needed to. So we have sources of data coming in. We've got data running in, coming into Pulsar. And in Pulsar, I've got one of those functions so that I can take this data and separate it out if I need to. I also can do, as we mentioned before, some analytics on the data. As you saw in that diagram, I want to get data, you know, using SQL, again, using, you know, the simplest means and something I think is the critical knowledge for a citizen streaming engineer to have. You got to know the basics of REST, maybe some tools like curl, know your way around what REST means, know SQL. If you know REST and SQL and can run some web applications, you can build some apps without some heavy lifting, pretty easily. So we've got Flink running. Flink is a very cool open source project we'll go into, and it lets us run SQL. And again, I'm just going to type some SQL here. It's nothing fancy, but what's cool about it is it's going to be built and deployed as an application for us. So I'm going to do a select here. What I want to do is be able to get the maximum of all these different type of air quality readings for a different region. And we're just going to have that run. So I'm just deploying that app by hitting return. So it's starting up now. It's going to take a few seconds. Let's make sure we're sending data still. Data's still coming here. And I could see it's, I got ozone, I got PM1, different regions, different types of data. I have that running every second, not to overwhelm my tiny little system here. Okay, so we can see we've got some data coming in already. And we're getting a max and min, average, how many rows we have for different areas around where air quality readings are available. So that's great. So data's coming through. If we go into our dashboard here, I could see that this is running, and this deployed this application for us into that cluster. So it's not just some simple thing doing this queries for us. There's a full application there, and you can see it's running. We're getting rows back. This is great. We've deployed this application. It's running. What else could I do with it? Well, to keep it to minimum coding, what's nice is let's keep that data in Pulsar so it can be shared. So what I'm showing you here is a simple dashboard. This dashboard is receiving data from those split out topics. So I've got one for PM2.5, one for PM10, one for ozone, and these are reading with WebSockets. So if you can do a simple web page, you point it to a WebSocket for Pulsar, and the full code is there, and this will give you a nice dashboard, not too hard. Obviously, if you have something like Jupyter, you could just point to either one of the storage areas that we're pushing to, Pulsar directly, or some other means to display. But this is a simple way of showing your data. Wanted to show you that. So let's stop sending data so I'm not going to run out of space here. So that'll shut down calmly, and then we're not going to get new records over here for this query, but just to give you an idea. Air quality, not looking too good in over here. Over 50 is not great. But then 9, that's really nice. So maybe there's some good air quality, bad air quality. You know how that is. Okay, so we showed you the demo. We'll probably pop back into it later to make sense of some things. And we showed you that. Links to everything, so you could try it out. If you have any issues, I'm on the Apache Slack. I'm in LinkedIn. I'm on Twitter. Send a request out and say, hey, I'm stuck somewhere. And we'll try to help you out. So first up, one of the key tools, big one I'm talking about is Apache Pulsar. Having that cloud native way to do messaging and event streaming is important. So you don't have to decide. You don't have to run a ton of different things to be able to do basic apps. And what's nice with cloud native means if I want to run it in Docker, Kubernetes, or in any of the clouds out there, it's designed for that. I don't have to do any special lifting. I don't have to buy a paid version. The Apache version works great. So why did I choose Apache Pulsar to do this? Again, having one place to do all the different types of messaging I want to do, all the streaming, just have one thing to learn, one thing to be able to distribute the data, whoever needs it, however they need it. I don't want to lose messages. I mean, this data is important. So that's table stakes. We got to have that. I need a system that's resilient because, who knows when something breaks, I lose network, I lose power. Needs to be resilient because, we may not be in the best environment where we're running it. And I need to be able to scale up because maybe tomorrow people love what I built, but now I need it distributed everywhere in the world. I need to have 1,000,000 times the amount of data. I need air quality readings from every part of the world, every sensor in the world, every, sub-second. Well, we could do that. Now, we talked about unified. What does that mean? It means you don't have to decide, you don't have to get rid of all the legacy apps you have already, because maybe you have some Kafka ones. Maybe you have AMQP, Rabbit apps. Maybe you're using MQTT for IoT. Maybe you have a couple Pulsar apps. What's nice with Pulsar is I could use all those existing apps, all those existing libraries. You don't have to rebuild things. If you've got something off the shelf, maybe someone wrote already, I can get that data into Pulsar and let other people consume it and use it, store it. That's a great thing. Now, a couple different ways we allow that flexibility is once you get the data in, which we've got lots of ways to do that, pulling it out is where there's a couple of options, and these define if something's streaming or messaging. Streaming really, key shared, lets me have subscribe to the data, and for a key, only one person can consume it. This is similar to what Kafka does, and this makes it easy for us to, be able to get things in order, get things exactly once. This is common for streaming, as I want, say, log data or time series data. As something happens, get it, get it done. For failover version, we're going to have one consumer always get the data. This is, again, similar to how Kafka works, but if something goes wrong, let someone else take over. Exclusive, only them. I tend to always say do failover, because what happens if somebody is no longer available? But you decide that. For messaging, we use shared. So whoever wants the data, subscribe, get it. This is great if you want to do a work queue. So, I have all these events happening, let as many apps process it, get those things solved, do it. So that's why we have the shared, and that comes in handy a lot. I tend to use that for a lot of types of data there. Now, we don't live in a vacuum. Pulsar is friends with a lot of people, especially other projects in the Apache Software Foundation, and some of the main ones I have linked here. And these are ones I tend to use with Pulsar a lot. Flink, as you saw in that demo. Spark, especially now that we have a really prime connector there. So we could do structured streaming there. I could do some streaming ETL. That's a great way to do some processing. Not too heavy there. Also runs wherever you need to run it. NiFi, you saw today, very easy. Easy to consume and produce messages from NiFi. There's some other ways to get data in and out. I mean, we have a client app. You don't always want to have to write code. So you got support for IO, which lets me have those sources and syncs so I don't have to write code, just configure it. Functions, get a little processing done. Protocols, so I can talk to Kafka. I could act as if I'm MQTT. This gives me a lot of options, so I don't have to rewrite the world. Don't have to change all the apps that I have. Data offloading is great. Get that data when it gets too large, store that in a cheap cloud object store. If I want to examine the data, but I don't want to have to write code or don't have to write a consumer, using Pulsar SQL, I could look what's in every topic, and it looks like SQL. Again, if you know SQL, it makes writing simple applications a lot easier. It is kind of the bare level language you should learn. If you're going to learn any language, it's great for analytics. There's a lot you could do with it in the streaming world as well. Now, we want to build data pipelines for streaming. And really, this is the idea. Keep it as simple as possible. Ingest data. That's bare minimum. I might just want to grab something from over here. Maybe it's a log file. It's like you saw this JSON from a REST endpoint. Get the data. That's step one. We got it. That's great. At a minimum, maybe that's it. Maybe you're happy. You get to see it once, it goes away. Most likely, it's got to do something else. Now with Pulsar, it makes it easy to route that, maybe do some transformation, enrich it, maybe change some of the fields like we did, add another field. We get a little more complex. Things like Flink and Spark can let me join it. So maybe I have multiple REST feeds coming in, maybe some for weather, some for air quality, humidity, and I might want to be able to put them into one set of data and hand that off to a data scientist to know, well, how healthy is it in this city right now? And I probably need multiple sources of data. Maybe I have some historic data to join. Joining data important, again, SQL. Knowing SQL is important. Being able to access other people's machine learning models, very helpful. Even as a non-data scientist, someone let me point to a model, it just runs for me and I get the results. Maybe I use that to enrich my data. That's really great, because if the models aren't used by typical analysts and regular people out there, maybe they don't get used. Why spend all that time developing all this machine learning models if we're not using them? At the end, almost every use case, storing the data, and it's cheap to store data now and very easy with Pulsar, whether it's a few hundred records or trillions of records, petabytes of data, store that data very easy. Now we showed you Apache NiFi in the demo. There are some features besides that nice drag and drop and cool UI that make it, something I like to have in almost every use case, unless there's a reason why I don't need it. Guaranteed delivery. I know I'm getting my data through there. It's got a great way to do buffering and back pressure. If I send too much data, it'll slow it down for me. I can prioritize data. I can decide, how quick I want it to go through. With data provenance, I can see the lineage of everything coming through the system. This is great for auditing. This is great when you're developing or trying to debug. Why'd the data not show up anymore? Why is this looking weird? This lets you know. You can pull or push any kind of data very easily. Lots of different drag and drop processors to make you a powerful engineer without having to know much code. Security in there to keep you safe, and clustering when you're ready to expand out. Get as many nodes of this as I need, and version control my my little diagrams there, so I don't have to lose things if the server crashes or I want to move that to another cluster. Version control important for programming. Got a great article out there showing you how to do that against Pulsar. Very easy to ingest data, do some cleansing in NiFi, then get that into Pulsar to exchange with everybody else. And same with consuming. I might want NiFi to consume it, maybe push it somewhere. Very easy. Again, not having to write code is nice. I can use Pulsar to ingest my data. Pulsar has a number of different sources, as we mentioned, for things like Delta Lake. So I get my data, get into Pulsar, and then it can easily be shared with other applications or users. Very helpful. We want to be able to route the data around, often transform it. Nice to be able to enrich it. I could do that with libraries, so I could do some end client code, do it in functions, and I have a nice function here that splits out the air quality for those different types and reformats it. Again, pretty simple in a function. Those connectors so I could store it somewhere when I'm done. Being able to not have to be all in on one protocol for messaging, whether it's AMQP, Kafka, MQTT, native Pulsar. Being able to tier that out into simple storage without having to write any code again. Nice. I said you only have to know SQL. Well, you really should know what a schema is. Now, if I'm writing the code or someone wrote it for me, Pulsar lets me just create a very simple class, just name the fields, give them a type, and it will build a schema for me. I recommend JSON. That's the simplest to understand, that works with most of the sources and sinks and most of the things out there, maybe a little verbose, it's not binary. It's a little easier to understand. If I use a schema, I set it up once, we have a contract between everybody. This is helpful if you're not, you know, the a 20-year experienced high-end data engineer. Everyone agrees on the schema, keeps the data consistent, gives me a contract between all these applications, keeps the data clean. I know if it's going to have an ID, it's going to have a name. I know it's this type. I know it's not null. This is helpful. This also makes it very easy for us to do that Flink SQL, to do that Pulsar SQL, to do Spark structured streaming. This makes everyone's life easier. Request a schema. If you need help with it, let me know. Having a schema will make your life much better. Everyone else's life better. Just do it. Pulsar functions, again, maybe a little advanced for you to start out with, because you got to write it in something like Java or Python. But it's an easy way to add some functionality. And this is something, once deployed, anything from multiple topics can use this. So this is something that maybe you have one data engineer develop a bunch of these, and then these can be used and put together as part of your data pipeline. Again, something you won't have to be a developer to do, to use these functions and say, okay, if something goes into this topic, it's going to come out in another topic in a new clean format. This makes it easy for me. I can change with some DevOps very easily without coding to add another topic so something else gets that function. Whether it's something as simple as make everything lowercase, do maximums on things, join fields together, lots of different things you could do there, call a ML model. It could be very straightforward. I built an article around how to do this for basic AI. So download that if you're interested in how could I use these functions to build, an event-driven ML system. Not as hard as it sounds, actually. Now, lots of different things we could do with these ML models. Again, what's nice is you don't have to be a data scientist. Someone else will write these. There's a lot of pre-built ones out there. Very easy to get them deployed. And then once you have them, this adds some really nice functionality to what's going on with your data. Sentiment analysis. I have some things where I have a form. I want to get data from people. Maybe I'll run some sentiment on it. Maybe I'll use some natural language processing to pull out key terms, cities, states, money, things that I might need to know with that named entities. I could do some predictive analytics on it. So as, sensor readings are coming through, I could say, hey, this thing could say, oh, look, the air quality is getting really bad. Everyone get a stronger mask on or get inside and don't go out yet. And, predict how is that going to be over time based on what's going on now. Helpful to have, and it's very easy to add these functions in a chain. Just keep adding another one, takes the input from one, goes to another, can add extra analytics, add them where it makes sense, and reuse them pretty easily. Now, we're using Flink, and I showed you a little bit there, how easy that is. But one thing that Flink is great for is joining those different streams together. So maybe I'm joining the air quality stream from different countries, putting that into one global stream of air quality, or mixing the air quality and weather, joining on a city and time. Different ways you can look at the data. Again, knowing SQL, even in these, real-time applications is important. With basic SQL, you can get a lot done. And even in Spark, yeah, it's code, but this is pretty boilerplate. You paste this in, and I'm getting the data from a Pulsar topic. You change your topic name there, and I'm going to output that to a Parquet file, which any of the data engineers would be happy to get that format, and they could build their applications off that. And you've created a pretty powerful application without much heavy lifting. I will say one thing here real quick. This name here, persistent public default air quality, tells me this is a stored topic. It is in my public tenant. So multiple people can use one Pulsar cluster without any security or issues there. This makes it great for your company to run, a big Pulsar cluster and have lots of different apps there. Default is my namespace. I give them all different names under those different tenants. So for all your different applications, keep it clean and make your topics make sense for the data that's going through them. Now, we got that data, we got it cleaned up. Let's send it somewhere. There's nice syncs where I just set a little configuration and send it right to all these modern, really advanced lakehouse formats. And it's just some configuration. It's a very nice way to do that. Simple data pipeline we were showing. NiFi gets the data, comes in and out of Pulsar, makes it easy to share that data to different clusters, different places. Maybe you share this with other people you're working with or other companies very easily. And a typical advanced application, I have maybe some IoT, maybe that's going right into Pulsar. A lot going on there. I don't want to bog down in a diagram like that. We showed that air quality monitoring. We showed you could do a lot of different things with Pulsar. I didn't mention a little more advanced use case, but not that hard to set up. I could turn on geo-replication, and that data can automatically get sent to another cloud, another region. Makes a great way for you to distribute your data. I call using these things together FlipStack. So if you search online, you'll find me talking about different applications, give you some ideas what you could build. Got a nice article on doing this for the at the edge. Pretty straightforward, but gives you a nice walkthrough. And join me every week. I try to put out interesting articles around open source, different talks I've done, interesting videos, lots of things there. Not too heavyweight. It's on LinkedIn. Please join me every week. I'm Tim SPann. Thank you for attending my talk. If you have any questions, please put them into Slack or contact me. Thanks again. And it was a real fun talk. And I hope everyone enjoyed what we were doing and that it was all good. Thank you.